Welcome to clickmyproject.com. Let us discuss about the process called detection and classification of exudates using k-mean clustering in color retinal images. Let us discuss the abstract for the process called detection and classification of exudates using k-mean clustering in color retinal images. Here, diabetic retinopathy is an ocular disease which causes blindness in the world among patients suffering from diabetes. The retinal image in RGB is represented in CLAB color space to eliminate the noise. Then the image is clustered using k-mean clustering, and then the image is enhanced by using adaptive histogram equalization technique. Then the optic disc is marked using F transform. After that, we are classifying the exudates whether it is hard or soft based on threshold value and edge energy. First, the color retinal image is converted into CLAB color space to identify and classify the exudates. Then, k-mean clustering is computationally simple and effective, so we use it for clustering the retinal images. Adaptive histogram equalization technique is applied for the enhancement process. Then, by using F transform, the optic disc is detected. Finally, the exudates are classified as hard or soft. The advantage of this process is computer-aided detection of exudates will give fast and precise diagnosis, and the process time is faster than other clustering, and moreover the contrast enhancement is better. In this process, k-mean clustering algorithm is used for clustering the image. The k-mean algorithm is an algorithm to cluster n objects based on attributes into k partitions where k is less than n. It is similar to the expectation maximization algorithm for mixtures of Gaussians in that they both attempt to find the centers of natural clusters in the data. It assumes that the object attributes form a vector space. Simply speaking, k-mean clustering is an algorithm to classify or to group the objects based on attributes or features into k number of group. K is a integer called positive number. The grouping is done by minimizing the sum of squares of distance between data and corresponding cluster centroid. And then we conclude that the image was clustered using k-mean clustering successfully. After that, the optic disc is marked using F transform. Then, based on threshold value and edge energy, we successfully classified the exudates as hard and soft exudates. This classification helps the ophthalmologist for diagnosing the retinal diseases. Let us discuss the flow diagram for this process. In CLAB image, the retinal image in RGB color space is taken as input image. Then the retinal color image is converted into CLAB color space. The retinal image in CLAB color space is pre-processed to eliminate the noise. Again, the color retinal image in CLab color space is used to identify and classify the exudates, which yields better result. Then in cluster image, K-mean clustering algorithm was used for the detection and classification of exudates. K-mean clustering is computationally simple and efficient than other clustering algorithms. Then the retinal image is clustered by K-mean clustering. In the enhanced image, the enhancement technique used for retinal image is adaptive histogram equalization. The contrast enhancement leads to enhancement of separability between exudates and background. In this process, the contrast enhancement is better. Next, F transform. Here, F transform can also be used for detecting circles, ellipses, etc. Using F transform, we can detect the arbitrary shapes with no analytical descriptions is also possible. By using F transform, we can eliminate the optic disk. This technique removes the optic disk but does not ensure that the correct part of the image is eliminated. Then in the classification, finally the exudates are classified as whether it is hard or soft exudates. The exudates are classified based on the threshold value and edge energy. The classification helps the ophthalmologist in diagnosing the retinal images. This is the flow for this process. Let us discuss the running procedure for this process. Here the main code is in retina.m. Now we are running this file. This is the output screen for this process. First we are loading the image from the given data. We can take any image from this dataset, and moreover all the images are in TIF form. After loading the image, it is converted into CLab image for the removal of noise. Then the image is clustered using K-mean clustering. Next, the enhanced image. Here the technique used is adaptive histogram equalization for enhancement. Then by using F transform, the optic disk is marked. Then classification. We are identifying whether it is hard exudate or soft. Here it is hard exudate because these are the hard exudate. This is the running procedure for this process.